welcome to all of you. I am Dr. Parul Yadav, Assistant Professor at Department of Computer Science and Engineering in Institute of Engineering and Technology. Today's topic is symbol table and runtime environment. This lecture covers the topics as follows. First is symbol table. Under symbol table, contents of symbol table, then data structures for symbol table. Under data structures, topics will be list, self-organizing list, search trees, hash table, and then we will discuss runtime environments. So, first topic is symbol table. Symbol table is used to collect and use information about the names that are appearing in source program. So, compiler needs to collect and use information about the names that are appearing in source program. In source program, various names can be appearing. Names mean that variable, procedure, function, defined constants, labels or structures. So, each entry in symbol table is defined using a pair, and this pair consists of two fields, name and information. So, under name, name could be variable, procedures, functions, defined constants, labels or structures, and in type in information we store certain attributes related to names appearing in program. So, in information it could be type, mean variable is integer type, real type, string type. So, it is type. Next is the form, that variable is simple variable or structured variable. Then the location in the memory of the variable. Then the scope, scope mean variable could be global variable or it could be the local variable. So, next it could hold certain other attributes like array limit, like upper bound and the lower bound for the array that we are using. The parameters, parameters mean in procedure or in function there could be formal parameters. So, the parameters and the return value, mean functions may be returning some value. So, this is related to the information that we store in symbol table with respect to each variable that is encountering in source program. So, the thing is, whenever a name is appeared in a source program, first of all a symbol table is searched, and after searching the symbol table, if the name is not appearing in the list, then that entry will be made in the symbol table. So, each time a name encountered, symbol table is searched and the name is entered if it is new. So, if name is not in the list, then that particular name will be entered into the symbol table along with its necessary information at subsequent phases of the compiler. So, this may be separate, there may be separate table for the names. So, this is the basics about the symbol table. Now, we know that in compiler there are various phases. For example, lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation, and other two important components are symbol table and error detection. So, certain phases of the compiler will store information into the symbol table and certain phases of the compiler will use or retrieve the information stored into the symbol table. So, here lexical analysis and syntax analysis phase will fill the details about the variables in symbol table. So, lexical analysis phase and syntax analysis phases fills the symbol table, while the other phases of the compiler like semantic analysis, intermediate code generation, code optimization, code generation, these all phases use the information stored into the symbol table. So, first is semantic analysis. It is for checking that users the names are consistent with their implicit and explicit declaration. Then in code optimization, flagging temporaries that are used more than once. Next, in code generation, knowing how much and what kind of runtime storage must be allocated to the name. and last, that is error detection and recovery module. It's just like printing the error message, just like undefined variable. For example, there is some variable in the symbol table and whose entry is not made into that, mean it is not defined actually. Then error handler module, look it in the symbol table, if it is not defined, then error handler routine will generate a message and it will prompt the message like undefined variable. Now, we will discuss the data structures for symbol table. So, commonly used data structures for symbol table are linear list, trees, basically BST, that is binary search tree, and hash tables. So, first is linear list. Linear list, as we know in data structures, in the linear list a symbol table is maintained by linear collection of elements and this linear order is maintained by means of pointers. So, linear list is actually the simplest form of representation and it is inefficient with large number of entries and inquiries. So, if entries or inquiries are large, then this type of structure will be inefficient in designing the symbol table. Now, next is trees or BST type structure, where a tree type structure is maintained, where the record will have its two pointer, one is left and one is right pointer, basically left child and right child. In such organization, it shows better performance. Now, some increase in implementation difficult. So, it increases some level of difficulty. Now, next is the hash table. It is best in performance because in hash table type of representation, hash value is calculated for the names and with respect to that hash value, element is searched in that particular list only. So, in hash table it shows a best performance and greater programming efforts, but some extra space. So, some greater programming efforts may be required, but and some extra space may be required, but it decreases the time. Now, we will discuss these data structures one by one. So, first is the list. As I already told that list is a linear collection of elements where linear order is maintained by means of pointers. So, here this is the simplest list, where this is the simplest and easiest data structure, where we may use array or equivalent several arrays to store name and their associate information. So, here we use the array where information is stored like name and then its attribute, then second name and then its attribute or information, and then nth name and information related to nth name. And this is the place that has been occupied by various variables and their associated information, and this is the pointer that is available, and it is in marking, it is showing the first available portion in the array. So, these are the records and this is the first available position in the array. So, here new names are added to the list in the order in which they are encountered. So, first name is this, then second name and third name and so on. So, they will be stored in the order in which they are encountered. Now, in list we can perform two types of operations. First is retrieve and second one is insert. So, retrieve mean to find some element from the list. So, for retrieving the element, we search the list from the beginning, means suppose we are looking for particular variable, we will start the search from the beginning and the position till the position that is marked by pointer available. So, we will start from here and till this position that is marked by available. So, if record is found in this particular list, then associated information can be found in the word following next. Now, suppose desired name is this one. So, its associate information can be found at the location that is just next to it. So, we can get the information. So, while retrieval there are two types of cases. First is when record is found and second when record is not found. So, if record is not found, then we announce a fault. It means the use of an undefined name, mean a name has been used that has not been defined in the symbol table. So, this is about the retrieval where we are searching for the record, and when we retrieve there are two possible cases, one is found and second one is not found. Now, second is with respect to insert operation, when we want to insert some element into the symbol table. So, for insertion we scan down the list to be sure that it is not already there. So, first of all we will search again through the symbol table to check whether check that it is not already there. So, there are again two cases, first is if it is there in the list and second if it is not. So, first is if it is. So, we have another fault. What is the fault? That a multiple defined name, that name has been defined multiply. Now, second is if record is not in the list available in the list, then we store the new record, increase the pointer by the width of symbol table record. So, if it is not in the list, then at this location that is marked by this available pointer, that particular name will be stored, and its associated information can also be stored in the subsequent phases. So, in that way we can insert the record, and now the available pointer will point to the next available location, it will be updated. So, this is about the two operations related to list, retrieve and insert operation. Now, we will just analyze the efficiency of list type of data structure. So, suppose number of names in symbol table n. So, number of records in symbol table is n. Work necessary to insert a name is proportional to n. So, for inserting a name, first we will scan the traverse this list from top till this location. So, we will traverse the records one by one, and if it is not in the list, only then that particular record will be inserted. So, work necessary to insert the name is proportional to n. Now, average searches to find the data will be n by 2. On an average we can search the elements by n by 2. Now, next is cost for inquiries is proportional to n. So, cost of inquiries is equal to work to insert actually, and this will again be equal to n, and average search we know that is this n by 2. So, now we can calculate the total cost to insert n names and m inquiries. It will be Cn n plus m, where C is a constant, it is representing the time necessary for a few machine operations. So, this is about the analysis or the efficiency about the list. Now, next data structure that can be used for designing symbol table is self-organizing list. So, in self-organizing list, substantial fraction of searching time is saved at the cost of little extra cost. So, at every record we attach some one field that is link. So, we already know that we have name and information, every record will be associated one field that is link. So, this is link field of record 1, link field of record 2, link field of record 3 and link field of record 4. Now, here this is the link pointer is this is first, and it is pointing to name 3. Now, here we have link field, link of 3 will point to certain record. Now, suppose it is pointing to first record. Now, link of 1 is suppose pointing to this particular record name 4, and link of 4 is pointing to this particular record. So, in that way link field is maintained, and available is showing the first available space in this list. So, new information will be kept over here, and linked pointer will be updated. Now, the beauty of self-organizing list is names that are referenced frequently will tend to be at the front of the list to be found quickly. So, the record that we want to search, it will be kept at the beginning of the list. So, how it is done? It is done using these, by changing these 3 pointers. So, first is link of P will be link of I, link of I will be name P, and first will be updated as name I. Here link of I mean the record that we want to search. This is the ith record that we want to search, and P mean the parent record to this node. For example, here the list is maintained like 3 is pointing to 1 and 1 is pointing to 4 and 4 is pointing to 2. Now, suppose we take one example, and here in this example, suppose we want to search fourth record, name 4. So, we want to search this particular record. So, first pointer will point to this particular list, this particular record. Now, link pointers will be updated. Link of parent mean parent of 4 is this one, this is P and this is I. So, parent of I, this will be updated, parent of I will be link of I. So, link of I is 4. So, parent of I mean parent of I will be link of 4, it will point to this one. So, first is here, that is this record, and now link of I is equal to name of P. Now, this is link of I, this is link field of I, and this will point to name of P, right. So, in that way we will update it. So, here this will point to this, and this will point to this, and this points to this. So, the pointers can be updated in this record in that manner. So, this is about the self-organizing list, where we attach one extra field, that is link, and it is helping us to reduce the searching time. Next time, suppose we have some set of elements that are frequently used in a big program, then that set of elements can be kept at the beginning of the list. So, the searching time for that particular items can be reduced. So, this is about the self-organizing list. Now, another data structure for designing symbol table is searched tree. Searched tree mean here we will use the data structure, that is binary search tree, where there will be a parent node and that will have its left child as well as the right child. In BST we already know the property is key value of this node will be less than the key value of its parent node, and key value of this node mean the node that is at right child of parent node. Key values of this node will be greater than or equal to the key values of this node. So, these we already know the property of BST. So, in this data structure P is the pointer to particular node. So, while P is not equal to null, we will apply these 3 steps. What are the steps? First is, if name is equal to name of P, name is the item that we want to search in the symbol table. If it is equal to name of P, then we can say that the name is found and appropriate action may be taken. Now, second case, if it is not equal to, then item can be found either at left subtree of that node or at right subtree of the node. So, it will be found in left subtree of the node if item is less than that value. So, if name is less than name of P, then we will go to left child of it, otherwise we will go to the right child of it. If after executing the steps, if record is not found, then we can say that we fall through the loop and we have failed to find the record. So, the time needed to enter n names and makes m queries, it is proportional to m plus m log n, because suppose there are n records in the table and we want to search particular record. So, average path length for searching a record will be log n. Now, another data structure is hash table. So, hash table there are very many variants to use the hash table. So, first here we will have 2 types of table, hash table and storage table. Hash table consists of words from 0 to k minus 1, like 0, 1, 2 up to k minus 1, and storage table words points to storage table to the heads of k separated linked list. Now, here we can perform the two operations, inquire name or enter name. So, for inquiring name, we calculate the hash value for that particular name, and suppose hash value for that particular name, and suppose this is pointing to particular list, and then item is searched only in that particular list. Now, suppose we want to enter a name, then we create the record for the first available space. First record is created, and then link to that record is pointed by the beginning of this index. So, first we will create this record, suppose this record is created, and it will be linked to the appropriate linked list, mean that is calculated linked list corresponding to M nameth record, H and nameth record list. So, designing hash function should be designed that it should be distributed uniformly among k names, and H should be easy to compute. Now, capability of performing MSs or n names in time is proportional to m into m plus m divided by k for any constant k. Now, we will discuss runtime environment. A compiler must allocate resources of the target machine to represent the data object manipulated by the source program. There are two types of data types, elementary or aggregate. Elementary represented by the equivalent data object at the machine level, and aggregate represented by several words of machine level. There are two types of storage, static and dynamic. In static, all names are stored at compile time, while in dynamic, records are stored at compile time as well as runtime. It is fast, it is slow, it does not implement recursion while it implements recursion. Now, in the implementation static store, first here we store the local variables or global variables. This is a space for global or static data, and this is the top pointer, and here we have the store for storing records, activation record for P, and then extra storage for it, then Q, then extra storage, then R, then extra storage. A particular activation record can be defined like, here we have local data, then old pointer SP, then the value, return value, then return address, then the argument count, and the value of actual parameters. So, this is the organization of activation record, and for the various procedures we can operate, we can write the 3 address code to push the data into the symbol table. So, we can write the code for the statements like parameter T1 up to Tn. Another instruction can be called Pn. So, this can also be translated in the form of 3 address code. Then form can be for procedure beginning. So, we can again push the elements into the symbol table. Then statement could be the run statement. So, idea is that for every statement 3 address code can be written and the values can be pushed onto the stack. Similarly, at the end of the program we will find proc end and the appropriate translations can be done, but the difference is here we will not store the return value. So, in that way we can maintain the symbol table and we can manage the runtime environment. Thank you.